Okay, Bismillahirrahmanirrahim. Answer for day 1, page 1. Okay, so first one, we have a cat moving to the right and then come back to Q. Okay, and want to find displacement. So displacement, we just consider the initial point O and the final point Q. Okay, so because displacement is vector, so it has magnitude and direction. So magnitude is 6 meter, direction is to the left, so it means negative, so the answer is negative 6 meter. Okay, and second one, we have a cyclist riding at 8 meter per second. So this one is U, initial velocity, and acceleration A. So we want to find the velocity after 5 seconds. So 5 seconds is T, so we want to find V. So we use equation A equal to V minus U over T. So is A is 4, V is to be calculated, U is 8, T is 5. So we can rearrange 4 times 5 plus 8 is equal to V, and the answer is 28 meter per second. Right? Next, we have a car travels with velocity 15 meter per second. So this one is initial velocity U, and it accelerate and cover a distance of 12.5 meter, and the final velocity is V. So it means because V is lower than U, it means it is decelerate. So we expect to have a negative acceleration. Okay, so we want to find acceleration. So we can use equation, because we cannot use A equal to V minus U over T because we don't have T. So we are going to use V squared equal to U squared plus 2AS. So V is 10 squared equal to 15 squared plus 2A to be calculated, and S is 12.5 meter. So we can rearrange to get A equal to 10 squared minus 15 squared over 2 times 12.5. Okay, so we will get negative 5 meter per second per second. Okay, so it is a deceleration. The velocity is decreasing. Next, we have an aeroplane taking off. So the acceleration is 40 meter per second per second. So this is A. 10 second is time. So we want to find minimum length. So it is a displacement. So we are going to use equation S equal to ut plus half at squared, where although it didn't mention the initial velocity, but aeroplane before anything the initial velocity is 0 meter per second. So S equal to 0 plus half, A is 40, T is 10 squared. So we will get 2000 meter. Okay, so 2 kilometer, which is reasonable for the runway of an aeroplane. Next, we have a train and a girl standing on a platform. So the train starts from rest. So it means U equal to 0 and acceleration A. So 24 seconds is time. So we want to find the length. So this is displacement. Again, the suitable equation is S equal to ut plus half at squared. Every time you must rewrite the equation. So S equal to 0 because U is 0 plus half, A is 0.2, T is 24 squared. So this one is equal to 57.6 meter, which is a reasonable length of a train. Next, we have a student running 200-meter event. So this one, we have a distance versus time graph. Okay, so we want to find the speed at mn. So it is from n to n. So because speed, the unit is meter per second, so over here is meter, over here is second. So we want to find the gradient. Okay, gradient. So we have gradient equal to 200 minus 100. Up here is meter, and below is 32 minus 18 second. So it give us 7.14 meter per second. Okay, that's the answer. Next we have a diagram of displacement and time. So we want to find the velocity, same velocity unit meter per second. So it is the gradient of this graph, of displacement time graph. But the tricky part is when object returns. So return to its original position. So original position is 0 meter. So it is over here. So we need to find the gradient here. So gradient is equal to 15 minus 0. Up here the unit is meter, and below is 8 minus 11 second. And so the answer is, so note that the denominator 8 minus 11 will give us a negative value. So it is because if we look at the graph, the object is moving forward and then stay and then moving backward. That's why our velocity is negative. Okay, so we will get 15. So we get minus 5 meter per second. Okay, this minus means backward. So it is moving backward. It's coming back to its original position. So for example, the ball moving to the right, and then it bounce back to the exact position. Okay, next we have a velocity versus time graph. Okay, so we want to find total distance. So unit for distance is meter. Okay, so it will be the area here, because when, for example, when we try to calculate the area over here, so it is negative. So we have a rectangle, negative 30 meter per second times times 2 second. Okay, so times 2 seconds, so second is cancelled, so we will get negative 30 meter. And then we have a triangle, so we have negative, over here we have negative 30 meter per second times the time here is 1 second. So second, so we will get the area of a triangle over here is negative 15 meter. So but we want to calculate a distance. Okay, so distance is just magnitude. So the answer is 75 meter, because it is, sorry, yes, over here is 60. So 60 plus 15 meter, so 75 meter, right? So that is all for today. Thank you. Please revise this video if you don't understand, and don't hesitate. You can contact teachers and also me if you are not from my class. if you got any question. Thank you. Bye.